Okay, so starting with number 1 on this review, we're looking at this chart. Let me copy it real quick. 10, 12, 15, 16. Alright, cool. So on this, it wants a trapezoidal approximation with 3 subintervals, and it says 3 unequal subintervals. So I'm just going to look at these 3 right here, 10 to 12, 12 to 15, 15 to 16, and you do have to know this formula. Have to for trapezoidal approximation. The h is going to be the difference between each of these on the x-axis, and the b1, b2, these are going to be your bases. So for the first subinterval, this is base 1, base 2. Then when you scoot over, this is base 1, this is base 2. So all that you'd have to do is actually math it out. And we're adding all these trapezoids together. So the first one is from 10 to 12, which is a distance of 2, and then b1 plus b2. I'm just going to copy that down. Okay, plus the next one goes from 12 to 15, which is a 3, and then 20 plus 50, and then the last one 15 to 16, and then base 1 plus base 2. Now, I don't have, this is all my h's and b1s, b2s. I need to put all of these over 2. Just to make sure I match this formula here, and then you're just going to math it out. Just type it in the calculator and get yourself an answer. Hey, what'd y'all get on number 1? 90? 200? Okay. Let me do this real quick. $50, and that's 130. 60, 190, 290, 390. I think I'm getting 200, but grab a calculator and type it in and you'll see if that's right. Okay, so for number 2, the solution of the initial value problem. This right here, when it's written this way, it's giving you the derivative. So this means derivative, and if it wants the solution, it really wants the y equals equation. So to work backwards, I know I have to integrate, and that's going to be step 1. Now to integrate this, this could be my u, because it's stuck inside of another function. My derivative would be 2 dx, and I don't see a 2 dx, so I'm going to move that 2 over as a 1/2. And now I'm going to recopy this, okay? So all of this will turn into a 1/2 cosine of u du. And the integral of that is just sine, so it's 1/2 sine of, it'll end up being a 2x, okay? That's my answer, plus c. But the idea on this is that sometimes you're done. You really are. But in this problem, it also gave you a point. So if it's giving you a point, then you're just going to plug that point in and actually find your c. So I'm going to write 1 equals 1/2 sine of 2 times 0, and then plus c. Now 2 times 0 is 0. The sine of 0, 0 is over here. The sine of 0 is 0. So c equals 1. So my final answer is to go back and rewrite everything with the c, and that's what we're looking for a particular solution. Okay, so number 3, this is a good one. Find k if this is true. And the hardest part here oftentimes is the algebra. All right, and all of this is supposed to equal 12. So we're going to use the fundamental theorem of algebra, where we're going to let f of 2 minus f of 0 equal 12, okay? Now, you don't just get to plug in 2's and 0's right now. You actually have to integrate first, okay? So when we take the integral of this, we're going to get 2x to the 4th over 4 minus k x to the 3rd over 3 plus, okay, 2k, there is no x behind behind it. So that means it's just a constant. So the integral of that is just the constant times x. We're going to do all that from 2 to 0, and it's going to equal 12. So now I get to plug in my 2 and my 0 and do all that. So when I plug in a 2 here, I'm going to get 16 divided by 4 is 4. I'm going to get 8 minus 8k over 3 plus 4k minus, then I'm going to plug in a 0 everywhere, which is going to be 0 minus 0 plus 0. And all of that equals 12. Now, I'm going to start to combine like terms. So I've got a negative 8 over 3 plus 4k. I'm going to move this 8 to the other side. So that's a 4, and this is what I'm supposed to solve. So for me, I would get a common denominator. If I put this over 3, this becomes a 12. So a negative 8 plus a 12 is a negative, it's positive, 4k over 3 equals 4. And then when I solve this, it looks like k is equal to 3. And that's it. Okay, for the next one, number 4, area. When you're asked to find area, that should come to mind immediately. And we just need our bounds for area. And that's what all that stuff at the back was for. It's bounding you by x equals 0 and x equals the square root of pi. And the function that you're looking for is this. So this is our problem. And once you solve that out, you will have found the area. So I need a u sub, because this is complicated. So the innermost function is right here. So I would let u equal x squared. Then my derivative is 2x dx. I'm going to move that 2 to the other side as a 1/2, because now I can get rid of all of that. So this becomes 0 square root of pi, and this will just be sine of u du. Well, the integral of sine is actually, oh, sorry, I forgot my 1/2. There is a 1/2 here I forgot to bring over, so I'm just going to stick that in the front. The integral of sine is negative cosine.
Bye, Miss Meg. I love you.
So we're going to, now that this is the integral, we're going to go from the square root of pi to 0. So if we plug in the square root of pi, we're doing negative 1/2 cosine of square root of pi squared is just pi, minus, recopy, negative 1/2 cosine of 0. So we just have to math this out. The cosine of pi, well, pi's over here, and cosine means x. So the x value here is a negative 1. Minus, in this parenthesis, it's negative 1/2 times the cosine of 0. Well, 0's over here, and the x value there is a positive 1, and so this is my math. So negative 1/2 times negative 1 is positive 1/2, and then it's going to be minus a negative 1/2. So final answer is 1. All right. Skipping number 5 and going down to number 6. On number 6, it's almost the same exact thing as number 2 that we just did a second ago. You are given a dy dx. Oops. And you have to cross through a specific point. So we're going to need to work backwards to get our solution. So our answer is y equals something. That's what our goal is. And to do that, we need to integrate. All right, so I'm going to start with doing the integral of this. I'm going to let u equal whatever's under the radical, because it's the innermost function. So I choose the u because that's the innermost function there, and then the derivative of that would be negative 2x dx. And when I compare to this thingy, I see an x dx, but this negative 2 is going to be a problem, so I'm going to divide it to the other side. And what that lets me do is come back up here and substitute everything. So the x dx is gone, and it's now a negative 1/2 du. Notice I like to put the coefficient in the front, the du in the back. The square root is still there. I never got rid of it here. But under the square root is just going to be a u. So I need to handle this. This is really the same thing as u to the 1/2. Keep that in mind. And when I integrate u to the 1/2, I need to add 1 to it. So it becomes u to the 3/2, and instead of writing over 3/2, I'm going to make that times 2/3. And I still have this that is in the front, so these are just multiplied together. And then we cross that out, cross that out. I'm going to plug my u back in. So it's negative, what was u? 9 minus x squared over, and it's to the 3/2, over 3, and plus c equals y. So this would be my answer if they had not given me a point. So now I have to plug in the point. When I plug in a 0 for this x, I would have, and my y is over here, I'm going to have negative 4, and then negative 9 to the 3/2 over 3 plus c. So all I did was plug in my 0 here, and it got rid of that. And 9 to the 3/2 is totally doable. It just means take the square root of 9 and then cube it. So the square root of 9 is 3. 3 cubed is 27. So I'm going to have negative 27 over 3 plus c. Well, that right there is a negative 9. And then I'll add 9 to both sides to get rid of that. So c is 5. So when all is said and done, this is my answer. I just have to come back to the 5, and instead of putting plus c, we're going to write it like that. And that's how your final answer should look on number 6. Okay, the last one on this video is going to be number 7. And on number 7, it's a midpoint approximation. And there's this huge table, right? And I don't want to do every single one of them, dot, 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 dot. Okay, but the idea is this. You're supposed to go from 0 to 10 in 5 equal subintervals. Well, that just means, you know, a space of 10 divided by 5 means that every 2 you need to draw a new subinterval. So my first one goes from 0 to 2, then it'll be from 2 to 4, and then 4 to 6, and so on and so forth, all the way to 10. And if we're doing a midpoint approximation, we're doing rectangles that are a length across the bottom, or a width across the bottom of 2, times whatever the height is in the middle. And so the middle from 0 to 2 is 1. I need to look at the y value that was right there. So when I set up my formula, all I'm doing is stealing all of the heights that are in the middle of each subinterval, and that is how you are going to calculate this. And then I don't have a calculator, so I'm actually not going to finish this out. I think that was actually all of them. But once you type all that in, you'll have your answer.